Hello there. I thought I'd make you a quick little video of another row reduction example. So I hope you enjoy. Now remember last class, Thursday, August 30th, we were talking about how to find the reduced row echelon form of an augmented matrix. So that's what I'm going to be doing. Now in class, we liked to put a little line right here to remind ourselves that the matrix is indeed augmented. I encourage you to work along with me in the video, and you might want to go ahead and add that line in your own work. If you like, you can pause the video and see if we're on the same track, if we're getting the same answers. So, looking at this matrix, what do you suppose you would do next? Keep in mind, our goal is to try and get some zeros in the bottom left-hand corner. What I chose to do is add row 1 plus row 2, and that's going to become my new row 2 in my transformed matrix. And this is the result. What do you think we should do next? I thought it'd be a good idea to take -2 times row 1 and add it to row 3 to get our new row 3. Notice when I do that, I'm going to end up getting a 0 right here in row 3, which is what I really want to do. So this is my new transformed matrix. What do you want to do next? I thought it'd be a good idea to add row 2 to row 3 to get my new row 3. Then I will have my third 0 right there so that I have lots of zeros. I like that. So this is the matrix that results. What do you want to do next? I chose to take row 3 and multiply it by 1/2, and that's going to become my new row 3 in the transformed matrix. So my new matrix looks like this. What do you think we should do now? Now, reduced row echelon form matrix, now we want to try and find some zeros in a transformed matrix up toward the top on the right-hand side, okay? Not this column here, not our final column, but rather the previous ones, excluding our final column. I decided I should take -3 times row 3 and add that to row 2, and that will be my new row 2 in my transformed matrix. That's what it looks like. What do you want to do next? I'm going to take -3 times row 3, add that to row 1, and that will become my new row 1, yielding this matrix. We're getting really close. Now what do you want to do? I think we should take 2 times row 2, add it to row 1, and that will become our new row 1 in our transformed matrix. Okay? Wait a minute! I know who that is. Look, we have 1, 1, 1 down the diagonal in the coefficient matrix, and we have some nice numbers off to the right. That is the reduced row echelon form. That's what we've been working toward. But what does it mean? Think back to what these matrices represent. This means that in our system of equations, x sub 1 is equal to 1, x sub 2 is equal to -1, and x sub 3 is equal to 2. So if we were to plug those values in to any of our matrices, then we would end up with a true statement. Because remember, we have that nice theorem about equivalence, where anytime that we use the elementary row operations to transform one matrix into another, the solutions stay the same. In other words, this is our solution. Good job, everybody. And thank you for watching.